The first thing we need to talk about is how we should position the triangles on the coordinate plane. This is if we're not given a choice. Sometimes we're given coordinates that we have to follow. But if we're given the choice, we want to use the original as a vertex or the center of a triangle. We want to place at least one side on the triangle as the axis. You have to be careful. You can only place both on axes if it's a right triangle. But we can always place one side. Keep the triangle within the first quadrant if possible, and use the coordinates that make computation simple. So this is like if we're looking for the midpoint, then maybe we want to say 2a instead of a so that we don't have to divide by 2. So let's take a look at our example. Position and label each triangle on the coordinate plane. I have a right triangle. So that tells me right there that I can use both axes with legs AC and AB. So that's legs AC and AB. So I'm going to put A right at the origin. And then I'm going to put C here and B here. You could totally do it the other way around. Now it wants, so that AC is 2A units long. So if this is 2A units long, and I'm going from the origin over to C, C is on the x-axis, which means the y-coordinate is 0. So the x-coordinate is going to be 2A, so that when I do the distance from A to C, I get 2A. And leg AB is 2B units long. Well, this is going up the y-axis. So the x-coordinate is 0, and the y-coordinate is 2B, so that when I do that distance formula, and there I go. I placed it on the axes. And I labeled it. I forgot to label A is at the origin. Okay, now I have an isosceles triangle with FGH, the base angle, or the base of FG that is 2A units long. So this is when I like to use the origin as a middle. So I know that in an isosceles triangle, if I go draw the perpendicular bisector, it creates two halves that are equal of the bottom, and it splits the vertex angle. So I'm going to make the y-axis be that perpendicular bisector. So that means my base is FG, and it's 2A units long. So I want the distance from the origin, because that's the midpoint, to be A. So that means G is going to be A comma 0. And from the origin to F is going to be negative A comma 0. So the total distance from F to G is 2A. Now, I don't know anything about how tall it is. So G is up here, and I'm going to say that it's 0 comma B. And B is some value I don't know because it's not an equilateral triangle. So now finding the missing coordinates, identifying the missing coordinates. So here, we know that this is an isosceles triangle. So we know in an isosceles triangle, well, first of all, we know that X is at 0, 0 because it's placed at the origin. And we know that Z, the y-coordinate, is 0 because it's on the x-axis. So Z is A comma 0. Now the question is about Y. So we know that when we have an isosceles triangle, the vertex, a perpendicular line from the vertex to the base, is the perpendicular bisector. And we know that it bisects the angle. So since it's the perpendicular bisector, this point here would be A over 2 because it's halfway between X and Z. So our y-coordinate is A over 2 comma B because we have no idea how high up. I can't just say that it's B comma C, giving them both new variables because I want to use as few variables as possible. Okay, so letter B, We know it's an isosceles right triangle. Well, again, B is our easy one. Point B is the easy one because it's at the origin. C is a comma 0 because, again, it's on the x-axis. I know A is 0 comma something because it's on the y-axis. Now we have to focus on the fact that we were told it's an isosceles, which means our two legs are equal. So this leg right now is A units long because it's from A to 0. So this has to be A units long, which means A is going to be 0 comma A. Equilateral triangle. This is our most challenging. So W is easy again because it's at the origin. Now, this is challenging because we have to find the coordinates of Z in terms of A because we know it's an equilateral triangle. So knowing that it's an equilateral triangle also means that it's isosceles. So since from W to Y is 2A, equilaterals are special isosceles. So we know Z, the first coordinate, is A. We don't know the second coordinate, so I'm going to call it Y. Now we need to find that. Now we know that it's an equilateral triangle, which means all sides are equal. The side from W to Y is 2A. So that means WZ also equals 2A. So I'm going to do the distance formula on WZ, which equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And actually, now that I think about it, I want to do this in class with you tomorrow. So we will finish C in class. So now when we're writing a coordinate proof, to write a coordinate proof, you're going to use the distance formula to find sides, our slope formula to identify if we have parallel or perpendicular, and the midpoint finds the midpoint. So, example 1. Show that a line segment joining the midpoints of two sides of a triangle is parallel to the third side. So, position our triangle. So we know nothing about our triangle. Nothing special. So we can't make it isosceles, we can't make it right. So I'm just going to randomly plot 3 points A, B, C. Now, I know that I want to find the midpoints. So A is at the origin. B is on the x-axis, so it's 2A comma 0. C, we know nothing about. So C is going to be 2B comma 2C. I'm using all new variables because I know nothing about this triangle. I don't know its isosceles. I know nothing. So here's my triangle. Now the first thing we need to do is we need to find the midpoints. And I want to find the midpoints of the sides. So I want to find the midpoint of AC, which I'm going to call D. And I want to find the midpoint of BC, which I'm going to call E. I want you to pause and find these midpoints. Okay, so I found my midpoint. So I found that D is the point B comma C. And I found the midpoint of CBE is A plus B comma C. And I found that by just doing the midpoint formula. Now what I want to do is I need to show that DE is parallel to AB. Well, how can I show points are parallel? Lines are parallel. The slope. So I want to find the slope. So the slope is change in y over change in x. So I want to show, because I'm trying to show that DE is parallel to AB. So I want to find the slope of AB, and I want to find the slope of DE. So pause and find those. Okay, so I found the slope of AB by doing 0 minus 0 over 2a minus 0, which gave me 0. Gave me 0 over 2a, but 0 over 2a really is just 0. DE, I did C minus C over A plus B minus B, which gave me 0 over A, which is really just 0. So the slopes are 0, which means therefore AB is parallel to DE because they have the same slope. And that is true for any triangles. So that's actually a theorem that we just proved using coordinate geometry, which is in a triangle, the segment formed by two midpoints is parallel to the other side. Okay, and now second example. Prove the above by using distance. Oh, I just did that up there. So now prove the segments joining the base vertices to the midpoints of the legs of an isosceles triangle are congruent. So we need to position our triangle. Again, we're talking about an isosceles triangle. So how I like to do an isosceles triangle is so that the middle is on the origin. So I'm going to have A, B, C. A is going to be at negative A0. B is at A0. And C is at 0, comma B. Prove that the segments joining the base vertices to the midpoints of the legs, it says midpoint. So to make it easier, since it says midpoint, instead of doing A and negative A, I'm going to do 2A and negative 2A. And I'm going to do 2B. And I'm doing that because I want to find the midpoints. So I need to find the midpoint D and the midpoint E. So the midpoint D, again, I'm going to use my midpoint formula, which is x1 plus x2 over 2, comma y1 plus y2 over 2. So pause and find D and E. Okay, so I found the coordinates of D and E. D is negative AB, and E is AB. Making sure I didn't have space down here that I thought. So now I want to prove that the segments joining the base vertices to the midpoints of the legs of the isosceles triangle are congruent. So that means I want to show that AE is congruent to DB. So the question is AE congruent to DB? Well, the only way I can show congruence is the distance formula. So I want you to pause and find the distance of AE and find the distance of DB. Okay, so when we're doing the distance formula, we have to remember that negative 3a all in parentheses squared really means negative 3a times negative 3a, which gives me 9a squared. And then we need to remember that when there is a plus sign underneath the radical, we cannot take the square root of each. So the answer for the length of AE is the square root of 9a squared plus b squared. That cannot be simplified. DB is the square root of 9a squared plus b squared. Since they are the same, AE is congruent to DB. They have the same